And we are live. Welcome to another edition of the Linz Meetup. Stefan, hi.
Hi, good evening.
Can you believe it? It's already the 22nd Linz Meetup. We
Seriously?
have two meetups to go, and then we have our second birthday.
Oh, cool. That's great.
Yeah, that's absolutely great. And I think we didn't miss a single month since we have
Nope.
started, right?
Nope, we didn't.
Ah,
I guess we struggled a bit in December, but we even managed to do one in December.
yep.
So we managed to catch them all, and that's great.
Very Very good, very good. Okay, hey, we are looking forward to two awesome speakers. And before we get right into the first talk, let's do a quick community roundup and talk a little bit about what's going on in the Linz and Linz community. And for that, I'm going to share my screen, and we are quickly going through some slides that we have prepared together. In fact, a lot of stuff is going on in the upcoming weeks in Linz. So if you are into IT and you are looking for some interesting communities, we have some, I think, pretty good news for you. So first, as you all know, the Linz Meetup is brought to you by the Coding Club Live. This is a volunteer-driven coding club here in Linz, Austria. I will tell you more about another event that we are planning in a second. Today's speakers. Stefan, I am super proud today, or super happy today, because two of my personal heroes are here. Alvin is a great coder, and I'm proud that he is here with us today, and he talks about his experiences with Rust. He is very much into macros, and he told me some of the things that I know only a little bit about macros, and he knows a lot more about macros, and I'm looking forward to this first talk. And Radu Matai from Fermion will also be here, and I think this will be two super interesting talks. What do you think?
Absolutely. So, first of all, just as you said, I don't know anything about macros, and I'm super happy that Alvin will teach us because I'm pretty sure he will do great. And as far as I know, Rado is going to show Spin, which is some really exciting technology.
Yep,
So
yep,
I'm
yep.
really looking forward to this presentation. I guess when Fermion announced it, we were both blown away by what they've
Absolutely,
achieved. Can't wait to see it in
absolutely.
action.
Absolutely. I think still many people, when they hear about WebAssembly, they immediately think about WebAssembly running in the browser, building UIs with WebAssembly. But I guess that from Radu, we'll hear a lot about WebAssembly on the server. And I personally think this is one of the most exciting technologies that will shape our job in the future, our job as full stack developers or server developers. And that will definitely be an awesome talk. So, interesting evening tonight. Okay, let's dive into the community news. If you aren't a member yet of our Discord server, we invite you to join our Discord server. We will put in the URL in the chat in a second so that you can just click on it. And if you're interested, there you can reach us. If you have questions, maybe you want to propose a session of your own and you want to talk with us about it before you type it in, absolutely no problem. The Discord server is a great way to get in contact with us and with other Rust enthusiasts in our community. Now let's go into the meetup scene here in Linz. Our very own Coder Dojo, our programming club for kids, has a short pause this week because this week is, how do you say it in English? I don't know. Fenstertag, Brückentag, a kind of holiday. I don't know. Today's a holiday. Tomorrow would be a working day, but because everybody is on holiday in that day, we skip this week, and next
I,
week, yeah,
I guess they call it Bridge Day as well.
Bridge Day, Bridge
So
Day. Okay,
if
so
I'm not
tomorrow is a Bridge
mistaken,
Day. Yeah, so tomorrow, Friday, will be no courses. But next week, hey, we are looking forward to it. We are doing an in-person Coder Dojo at a school near Linz again. And we also do online meetings so that kids who visit us over the internet can also do some coding with us. So 3rd of, and that is a mistake, of course. That shouldn't say May. Sorry, I will fix it immediately. That's, of course, June and not May. I'm sorry for that.
Martin from the chat just said it's bank holiday.
Bank holiday. Okay,
Bank
bank
holiday.
holiday.
Yeah.
I see. Good, good, good. Now, our friends from Female Coders are also active. They will do their next study group on June 1st. If you are a woman or a girl who wants to get into coding and you are looking for other women and girls who do coding, who want to learn coding, then study groups from Female Coders are a great option. Take a look at their website. They have their dates and locations online. The Cloud Native Computing Meetup is also active. Their next meetup will be on May 31st. I'm very sorry, I don't know the topic now from the top of my head, but I have the URL here and you can click on it. I will share the screens in Discord, share the slides in Discord, so you have working links and you do not need to type it in on your own. So Cloud Native Computing links always definitely a very, very interesting meetup here in Linz. The next one is a community which is not directly related with Rust, but they are good friends of us. It's the Expert Life community. It's a community that is more focused about IT professionals, more the ops side of DevOps, but we know that many in our various communities are DevOps related developers and they care about development and they care about operations. So I thought it would be a good idea to point out this awesome conference, which will take place on June 29th. For the next one, Stefan, I would like to pass on to you because this is your home ground. Technologie Plauschel is back. I was so happy when I heard that.
Yeah, so the original Linzer meetup is back after, I don't know, more than 2 years. We're having another one at Natural on June 2nd. So that's next Thursday. And we already have 3 talks. And one thing that's great, the person here in the middle where we don't have an image yet, that's Stefan Schindler, who organized Rust Fest in Zurich and who spoke at our Rust Linz meetup already. And is going to show some more Rust stuff by writing a Grafana security proxy. So this is going to be nice. And yeah, so I'm happy that the Plauschel is back again. So it's I guess it's in the heart of every developer in Linz and around Linz, and I guess everybody's looking forward to meeting each other again. So we're very happy that we can do that
Linz
again.
was missing the Technologie Plauschel, and I'm so happy that it is back. And the second one is also one of your meetups or a meetup that is very close to your heart. Am I right?
Yeah, so I'm one of the organizers of Stahlstadt Jazz as well. And guess what? We are also back. We haven't the final date yet, but we are thinking about July 5th to meet again for some JavaScript talks in Linz. And yeah, we are going to announce everything rather soon. So check out the website or catch us on Meetup if you're interested in JavaScript, TypeScript, web development, JavaScript on the server. Then please join us. That's always a fun meetup as well. And we're definitely recording live streaming. So if you can't be with us in person, we try to make sure that you won't miss out.
Very nice. So a lot of things are going on in the upcoming weeks. Finally, we would like to thank very much our sponsor, Microsoft. They are supporting this meetup. And yeah, we want to say a big thank you to our sponsor. And that was the community news. So let's get rid of my screen here. And I think it is time to bring up our very first speaker. Hi, Alvin. Are you here? Can you hear us?
Hello.
Very good. Very good. Hey, we are super happy that you are with us. And I know the answer of my next question, but it is a kind of tradition. I ask that all of our speakers, where are you broadcasting from?
I'm from the end part. It's south from Linz.
I see. Very good. So you are a real local. We are super happy that you
Yes.
are here. This happens for the first time that somebody who a few months ago were still coding in our Coder Dojo, you are now in a meetup from our coding club, and that makes me super happy. Thank you very much for taking the time to prepare this talk and to give us a talk about macros. We said a minute ago, macros are used by many Rust developers, obviously, Without macros, you cannot do very much in Rust, but many developers, at least in my experience, they haven't really taken a look in how macros work, and therefore I think your talk will be very much welcomed by many developers. Okay, Alvin, I think you already shared your screen, right? So can I put it on the screen on
Yes.
stage? And here we are. Nice, good. So we have the slides up and running. And with that, we will leave the stage, and the stage is yours. And we are looking forward to your talk. Thank you for being here. The stage is
Yeah,
yours.
thanks for inviting.
The stage is yours, Alvin.
Okay. Okay, so this is me. I'm Alvin Ramskogler. I'm 14 years old right now. I actually have birthday in about 2.5 weeks. And I love programming as a hobby. And I also love creating compilers, fiddling around with custom programming languages. That's really fun. And I love birds. Okay, let's get into the talk. First, I want to talk about C macros to understand where macros come from. What are they? They're preprocessor directives. Maybe you've seen things like include in C programs. They start with a hash and then some name. And these are C macros. They're snippets replaced by the C preprocessor. And they're nothing more than string replacement. So you can't do complex syntax matching. That's only possible with Rust. They look somehow like this. This is an example. We have pi is 3.1415, blah, blah, blah. And macros can also take parameters, like in this case, circle area takes a radius and squares it and multiplies with pi. This is a more complex example. It takes the same macros and it calls the macro. Macro calling looks like this. We just put the name. It looks like a function call, but it's actually replaced by the preprocessor. What do you think this is going to print? Now you don't have to pull out your calculators. This is the output. And that's correct. But there's a problem. If we add +2 in this position, it doesn't output what we expect it to output. And this is the first problem. I calculated the correct result and it was 153 point blah blah, but it actually outputs 27.708. What is the problem in this case? Well, they're just simple string replacement. So if we look at what it replaces it with, it's pi times radius plus 2 times radius plus 2. And we can fix this by just adding parentheses around. And this will output the correct thing. And I have another example here, which is a very simple macro called sum. We actually don't need it, but this is just for an example. The parentheses are placed correctly here. Everything works fine, except for this. Because this is going to give us the same problem as before. It's 1 plus 2 times 2. So it will print 5. That's also not correct, because it should print 6. That's the second problem. And as you can see here, this is what it expands to. It's 1 plus 2 times 2. And that's, of course, wrong. And we can apply the same fix as before, just saying parentheses around here, and this works fine. This is what it expands to. And Rust solves all these problems. You don't have to think about string replacement. It correctly groups together expressions, so you never have these problems. But I actually experimented with C macros. I found out that they can do some very crazy stuff. I'll show you something here. This is a hello world in C. But if I say include Java, this is a file that I've written, I can actually say public class main like this, and Copilot actually knows what I'm trying to do. This is valid code. I can run it. It outputs hello world. And if you don't believe me, I can change this here, and it still works. If you look into this file, this is the entire macro thing. I actually got that from Reddit, I think. It was in C++, but I copied it for C. It was a bit hard, especially with these things here to correctly reduce the syntax tree, but it works. And I even prepared something more. Say TypeScript function main console dot, and now look at this. I even get autocomplete. I can now say log hello world. And it compiles and outputs the correct thing. But if I say console error, this outputs the second thing, and this is now red. And if we look into this file, it's actually just one single macro called function, which does all the things needed for this to work. Okay, we said Rust solves all these problems. Now let's take a look at Rust macros. What are they? I'm 100% sure you've already seen them because they're in the Hello World example. And they're called using the bang symbol. This is the Rust Hello World, and as you can see here, println is a macro, and this bang symbol means that it gets called as a macro. If you don't have this symbol, it won't work because the compiler will say a println is a macro, but you try to call it as a function. Now the thing is, in Rust, there are two types of macros. There are procedural macros and there are declarative macros. And the interesting thing is they're called both in the same way, both with name, then bang, and then an argument list. Procedural macros are basically subprograms, so you write Rust code that gets compiled first and then executed while compiling your program. The problem with this is that you have to compile code 2 times, which is slower than just 1 time. And that is what declarative macros solve. They're like function definitions, just a bit different. But they don't need a second compile cycle because they're just like functions or types. They're in your program. They don't need a separate crate. They're just inserted by the compiler. And I don't want to talk about procedural macros today. That's a very complex thing, but about declarative macros. And for simplicity, I'm just going to call them macros. Okay, a very basic example. How do they look? Like this. You have macro rules, bang, say hi to. This is the name in that case. This is the argument list. And this is the content of the macro. And macro variables always start with a dollar symbol, then the name of this variable, colon, type. There are multiple types like expression in this case, or statement, visibility, attributes, all these things. And they're called like the println macro using say hi to, bang, and then the arguments. The problem is they have to be defined before being used. You can have recursive macros, that works, because when calling, they're already defined. You can even define a macro above this, or below this. You can define a macro below here, call it in here, but it is defined when this gets inserted because we call it below the definition of this other macro. And I have to apologize for my title. It just fitted so well. It should have been syntactically macro rules the world. This was my title. Macros rule the world, because that's true in Rust. And this would be syntactically correct. Do you see the difference between this? Just a few similar chars, but the other one would be correct. Okay, how are they built? This is macro rules, say hi to. In this case, this is the name. And this is the macro content. This is call signature, how it is called. And this is the body of the macro. And you can actually have multiple of these blocks, but I will get to that later. Okay, a call signature. What is a call signature? It's basically a list of tokens. You need to use matching bracket pairs, which are parentheses, brackets, and braces. They can have patterns like we saw before, using $name, type. And this is an example. It has to be called using this is an example, expression, semicolon, expression. And every literal token, like in this case, this is an example, and semicolon, they have to be directly inside here. And patterns can be like an expression or visibility or statement or whatever. And they can have multiple tokens, and they're correctly parsed by the compiler. The problems are solved that C macros have. If we change the signature to that, that's a bit simpler than before. And this is the implementation. See println blah blah expression times expression 2. And we call it using 2 plus expressions, 2 additions. Rust correctly groups them together. We don't have the problem like in C, where it's just inserted, the simple text replacement, but it groups together correctly. And the same thing also applies for return values. So if we say like, if we replace this println with expression plus expression 2, and we call it and we say times 2, it will also work correctly. Okay, there is more complex syntax in macro headers. We have like a variable amount of tokens, so-called repetition or optionals. And a simple example is the vector macro. It looks like this. We can say dollar parenthesis, then again some list of tokens or patterns, closing parenthesis, separator star. And inside we can also do it the same way, dollar open parenthesis, content, close parenthesis, star. If we just try to use dollar item on its own, this will not work because it will say variable still repeating at this step. That will be a compiler error. And you can actually use different kinds of brackets when calling the macro. You can use parentheses, you can use brackets like in this case, or you can also use braces, these ones. This is also a very simple example, which just prints all the expressions passed inside here. Delimited by comma in this case, like you can see here, and any amount. We can now change this to plus to require at least 1. This will still work perfectly, but if we don't specify anything, the compiler will say unexpected token in macro expansion or something like that. I don't know exactly the error message, but this will not work. Now the problem is if we want to have a trailing comma, this will also not work because it will say expected end of macro invocation, but it got the comma. So what do? This is where 0 or 1 are also called optionals come in. You can, instead of the star, you can use the question mark to say either nothing or the things inside the parentheses. Now, I talked about multiple headers before. You can have multiple call headers in the same macro. You need them for alternatives. Rust macros do not support alternatives on its own. Like, you can say a repetition and then either this or this. That doesn't work. You need to use multiple call headers. And this is an example print named with a colon some expression. And we print it using a equals blah and the expression. Or B and C. This is the other output then. And another problem that C macros have is the so-called hygiene. And this is basically that when we pass something to the macro that has the same name, a variable that has the same name as something defined inside the macro, we will override it inside the macro and don't have access to it later then. But in Rust, we don't have this problem. Variables are scoped. And in this case, we cannot access number. It will say cannot find value number in this scope because the macro hygiene is defined outside of my function. We can solve it by passing an identifier token that's also a different token type. And another way to solve it is to define the macro in the scope of the variable. Like if you need a macro only in one function, you can define it after the variable has been defined, and then it will correctly access the variable. And this is the fixed example from before. Okay, debugging in Visual Studio Code is pretty weird. It's very inconsistent. I tried some examples and sometimes it works, sometimes it doesn't really. It works very well at the call side. So if you like pass a statement inside the macro, then everything works well. But it doesn't work always when you try to debug inside the macro. I have an example here. If you try to set the breakpoint, for example, at line 25, this doesn't work in this case, but in line 33, this works fine. They can be used across files, but it's not as easy as with functions where you can just add a pub keyword and then in a different file add a using at the top. Because they have to be defined before being used, you actually have to use an attribute called macro export because pub is not supported on macros. And this is an example. I have a file macros.rs, the macro my macro, which takes two expressions and adds them and prints them. And this is the attribute called macro export, which is added to my macro. And in the main.rs, we can say mod macros, and just right after it, my macro, blah, blah. We do not have to import it because it's automatically imported if it's in the same crate. If we import something from a different crate, you actually have to add a use blah blah. Like in lazy static, I'm pretty sure you've already seen lazy static if you work with regex a lot. Then you say use lazy static : lazy static, and that imports the macro so you can use it. There is a feature that is called decal macro. This is a nightly feature. Oops, I forgot the bracket here to update that. And it's an unstable feature that basically works like functions, where you can say macro blah blah. So it's just like a function definition. With functions, you have fn name, and with this feature, you have macro name. And in that case, you can actually use pub and import it. So they don't have to be defined before being used. And I looked at some internals, and it seems like it works so that the parser, the Rust program is parsed. Then it's checked and then outputted. And the parser, which turns your text into the syntax tree, does some magic, and it basically inserts a placeholder in the position where you call the macro and parses later when he has the information from where the macro comes. And it can be exported and imported with pub and use. And this is a simple example with pub macro my macro. Just like with functions, the argument list, which is the same as the macro call header we saw before, and then the body which gets inserted. And this is the main file with feature decal macro, mod macros, use macros my macro, and then we can call it. If we don't add this line, it doesn't work because it's a declarative macro, a declared macro. And I'm going to give you some examples now, some very basic examples. In this case, we have the hello world example. This is what every Rust programmer writes as his first script. And if we look at this, this is the macro. And if I press command, you can see it highlights it, and I can go to the definition. And as you can see, it's actually just a macro in the standard library called println. It matches it if you don't pass any arguments. It just prints a new line. Otherwise, it takes any amount of so-called tokens. TT is a token tree. It's either a single token, like comma or colon, or matching parentheses or brackets with anything inside, like multiple tokens, whatever. And it calls the print function with the format args macro. And I've prepared some examples here now. In the slides, I showed you this macro here. This is not really usable for production. So I thought we could use something that we learned before, so-called repetition. I'm now going to try to rebuild this macro so that all these things here work. If we now look at this, no rules expected token B, I deleted this, and also no rules expected D. Let's add some simple repetition here, like this, limited by comma. So everything that's inside here, any amount of times, and between or with a comma. Now it still doesn't work because we only expect an A at this position. So we can say $name ident. It expects any identifier here. And this almost works now. We have a problem with this here. We have to always put it inside here. And now I can show you this arrow. Variable x is still repeating at this step. So this doesn't work. We have to add the repeating thing here too. Now we have another problem, unexpected end of macro invocation. Missing tokens in macro arguments, which is here. So it says here we don't expect any more tokens, but we pass tokens here. How do we fix this? We can add an optional token here, a comma. And now this works. If we run this, run. As you can see here, it correctly outputs all these things, but it doesn't output the identifiers. It always says A. We can replace this with a format arg. But what do we put here? If we say name, we'll give it an error, cannot find the value A in this code, because it tries to access the variable A. Now there is a macro that's built into the Rust compiler, and it's called stringify. This. And if you watched carefully, then you will see there's something missing. It will say expected function found macro stringify. I forgot the bang symbol here. And now everything works fine. The stringify takes any amount of tokens and it returns the string representation. If we run this now, A, B, C, D, E, and the correct values. So everything works fine now. This is a very simple example of a macro, but it can sometimes also be useful to have these kinds of simple macros. But I have a more complex example here. This is a pattern you will see really often. Up enum color, some variants, and then display for color, and just some string formatting. You can see this really often in many crates. Or like this. And if we say let color red in this case, and we say print color, this works. But it's not very beautiful. As you can see here, we have a lot of code that we actually don't need, but we have it every time we write this kind of enum. So for example, I have written a macro called fmt-enum of macros. This is a file, but I will get to this enum later, this macro. And we can now say fmt-enum. I can move in this color enum, delete this here. This now says no rules expect the token comma. Why? Because I have to say equals. In this case, it's like this. And then I can say equals green and blue, yellow. Copilot even knows this. And like this. Here we can say R E. And isn't that much more beautiful? I don't need this anymore. This is way more beautiful than the old version we had before. But it does still work. Let's say inline this here. You can add some more prints. Red. And it still works like before. So how does this macro work? Don't be scared of this. This is normal things you see when writing macros. But I commented it, and this is the first thing. We see these two match, which the code highlights them. And this says everything inside here, any amount of times, without a separator. If we don't put anything before the star symbol, it has no separator. Then we can have any amount of attributes. This is called meta. A meta thing is basically the thing you put between these brackets when defining attributes. Then we have visibility. This can be either nothing or pub crate, all these things. Then we expect the literal token enum. Then the name is an identifier. And then these phrases here, which are these things. And then we have any amount of enum variants separated by comma with an optional trailing comma. This is what we've seen before. It's an optional comma after the list of comma separated values. In here we have attributes again for the variant, and then variant name. This is a bit complex. It's basically this here. We say we have an optional tuple variant, which these parentheses here, with any amount of name colon type, also separated by comma, but we need a minimum amount of them. Like we need at least one. And we also can add attributes to this. And the same thing for struct variants, which just uses these braces. And then after this, the equal symbol, which is this symbol here or this, a literal, which is a format string, and then after this, optionally, this here. And this is an interesting thing. We have an optional, and inside this optional, we have a percent sign, an optional percent sign. What would happen if we would move this out of here, like this? This is still valid, everything here. But we can now say, for example, this. Now say here, percent. This is valid, but we don't want this. What we want is actually inserting it inside here. It gives an error here, because it would expect, if it sees a percent sign, it expects a parenthesis, because it knows it is inside here. So this has to exist, this optional, so it expects a parenthesis after. And this parenthesis is just a list of expressions separated by a comma with an optional trailing comma. Move this again. And that's the entire macro header. And the implementation is not that complex. It's just what we've seen before, the enum with all the variants. And this is the trick. I'm using some kind of pseudo alternatives here, because Rust will give an error if we have both this and this. It would be valid for this head to put both, but it's not valid here anymore to put both. Then we implement display for this name. And this is basically just write. That's the format string here. And these are the format arguments. And that's the entire format enum macro. And I have a very interesting tool here, which is called cargo expand, which expands this macro. That's a tool you can install using cargo install expand. Cargo expand, I don't know the name exactly. I will send it later in the YouTube chat. And if we run this, we will see exactly what it outputs. This is what comes out as the enum. It's exactly what we had before. I can remove the hello variant. Exactly what we've seen before. And pretty much the same in here. And this is something very interesting, because the write macro is a macro itself here. And this gets expanded to write fmt, core fmt arguments, new version 1, all these things. And that's actually what happens in print line 2. It says print, an empty string, then a new display for the color, and then a new line. And this is the same for these two cases, this time with RGB and here with red. And I talked about lazy static before. I have another example for cargo expand here. This is a very simple lazy static example. With static ref example, string is hello world to string. This does not work when we don't use lazy static because toString is not a constant method. You can see here if we add const, this would work, but it's not a constant method. So we need lazy static in this case. And we can print it using the deref operator example. Run. This actually works, as you can see. And if we expand it, this is what comes out. It's a lot of code. You can copy it into a file. This is what comes out. A feature prelude import. This is some Rust thing. It's like all the often used things like vector or option. You don't need to add usings for them. You can just say like this. And this works because Rust imports this automatically. Then it uses the standard library macros. And now this is my code that I've written here. Use lazy static, lazy static. And this, everything from here to here is what the lazy static macro gives me. This is a lot of implementation detail. I don't really understand what it does. It's some very complex thing with init things and uninitialized memory. I don't understand that. And this is the println macro again. And we can actually look at the definition of this. It says any amount of meta of attributes. And then we have static ref. These are literal tokens. Name, type, expression. And then any amount of tokens again. That's basically, so you can have multiple, I can say 2, like that. And this also works because inside this, which is this here, it passes all these tokens back to the lazy static macro, and that's macro recursion. So first we go in here, we pass everything into this here. We look at the first thing and we pass the rest back to this macro, which in return passes back into here. And these were my examples. And I have some takeaways for this talk. Macros are a very powerful tool. It can help you a lot. They're safe. They're way better than C macros, like hygiene or the grouping things. They do have problems, like having to be defined before being used. But that is going to be solved soon with the decal macro feature I talked about before. And sadly, there are no alternatives in macro headers. I imagine having something like macro rules. So I can say I want any amount of either A or B. That's how I think about it. That would be cool. So I can call it using A, B, B, A, B, A, B, and so on. But that doesn't work currently. But they're very useful for your everyday's work.
Very nice. Thank you, Alvin. I think you are through, right?
Yes.
Very nice. Very nice. First, let me say thank you very much for this super structured presentation. You got me especially at the beginning where you first described what the problems in C are. Recently, I did quite some presentations in front of C or C++ audience. And when I told them in the hello world that the print line is a macro, they immediately stood they nearly stood up and left the room because they heard macros and they didn't want to talk anymore about Rust. So I think that was super, super valuable. Your picking people up in the C world and then showing that Rust has these are not the macros that we know from C. And I also loved, I have to remember that, this fact that you showed that in Rust you need a macro to export a macro. So next time when somebody asks me whether macros are important, I will point exactly that out. Stefan, what do you think?
Oh, I
Great
loved
talk,
it.
wasn't it?
Absolutely, it was a fun talk. Well done.
Yeah, very well. I also see some clapping hands in the chat. Great presentation. I see it here, or very nice. And I would like to second that one. I think this presentation was awesome because it was so clear, so nicely structured. I learned a lot. I have never taken the time to take a look at macros like lazy static and so on. It was super, super interesting. We have a question from Ivan. Ivan asks whether one can define a macro that returns expressions. Ivan has the impression that all your examples expounded blocks of code. Is it possible to return expressions that you can in turn use in a bigger picture? Like, you know what I mean?
Yes, that's actually true. I never had an example that returns something, but maybe you can show my screen again, please.
Of course.
Macros are just blocks of code, like I can copy this. Let value. This is valid code. And the same way I can return it from a macro. When I add a semicolon here, this does work, but it indicates that this is a statement. And if I were to put a block here, this would actually not work, because when I have a block and I don't have a resulting expression, when I remove this, it works. But a semicolon says this returns void, basically, and void doesn't implement display. But this works perfectly fine. And I can also run this, and it prints this number.
Ah, nice. Very nice. I think with this, the question of Ivan is answered. If you have any additional questions, let them come to, through the chat. And I think, Alvin, you are also on the Discord server, right?
Yes, I am.
Very good. That would be one thing that I would ask you to do, if that's okay for you. Are you willing to share your slides? I think they contain.
Yes, I can post them.
Very nice. So if you put them on the Discord server, that would be super nice, because if somebody watched that video and would like to reread what you showed there, that would be super useful. Thank you very much for doing that.
Yes, I can share them on the Discord.
Okay, good. Currently, I only see thank yous and great and clap emojis and
lots of clap emojis.
Lots of clap emojis. So people loved your talk. Thank you very much, Alvin. And if you hang around in the Discord server a little bit longer, maybe some additional questions come up and you can answer them on the Discord server.
Yes, I can try to answer.
Yeah. Okay. Very good. So, Alvin, thank you very much. And let's take the second speaker into the crowd. Hey, Radu. Hi, how are you?
Hey, can you hear me okay?
Yeah, we can hear you. What do you think about the macro talk? Did you like it?
Oh, that was awesome. We are recently starting implementing some proc macros that I'll show in a bit. And yeah, hearing that very structured way of describing and defining macros was really good. I'll have a look at writing some of our own. Thanks a lot for the presentation, Alvin.
Very good. Very well. Again, thank you very much, Alvin. We will now put you off the stage. And if you hang a little bit around in the Discord server, thank you very much. See you. See you no more.
Bye. Thank you.
So, Radu, I always ask our guest speakers, where do you broadcast from? Do we have an international speaker crowd today, or are you also in Austria?
No, I'm in Manchester, UK.
I
That
see.
might have been different last week, and it will definitely be different next week. So today I'm in UK.
Oh, so you are traveling a lot.
Yeah.
Okay, very good, very good. Yeah, we are very much looking forward to your talk. Different topic: microservices, WebAssembly, Spin, and Rust, and these things.
Yep.
Perfect. Would you like to share your screen so that we can try to bring up your slides and samples?
Sure. Can you see my screen?
Yes, and I already shared it. Radu, with that, without any further ado, we are looking forward to your talk. The stage is yours.
Thanks. Hi, friends. I'm Radu. I work at Fermion. I'm really passionate about WebAssembly, distributed systems, artificial intelligence, and the intersection between those things. You can find me on the internet most of the time. When I'm not around computers, I really enjoy classical music, cycling, bubble tea. This was my yesterday's bike ride, which I really enjoyed. And today we'll have a look briefly at what WebAssembly is, the new WebAssembly component model, which is a new thing that is being proposed at the W3 level. And then we'll see how Spin uses Rust and the component model to build a framework for microservices with Rust and WebAssembly. So before anything else, I'd like to briefly touch on what WebAssembly is. There's a lot of hype around WebAssembly these days, and it always helps to go back to, okay, what actually is this thing? And specifically, it's a binary instruction format for a stack-based virtual machine. In familiar terms, it's basically a compilation target that it was initially used to bring new languages to the web. So you can compile your C or C++, Rust, C#, Python, Ruby, and a host of other languages that compile to WebAssembly and bring that to the web. And that generates a binary format which runs in an isolated sandbox in your browser. And in the browser, WebAssembly has been around for around 5 years. And it has enabled a lot of applications, from running Doom in your browser to running Windows 95 to slightly more useful things like AutoCAD, Photoshop, Google Earth, and things like that. And the big promises of WebAssembly are cross-platform and cross-architecture. You don't really want to open a web page and then be prompted to, press this button to access the Linux ARM website, or press this one to access Mac x86, or things like that. You want to have true cross-platform and cross-architecture. You want a really compact binary size. You really don't want to wait around to download hundreds of megabytes. And associated with that, fast startup times. You want to access your page instantly and have it interactive. And very, very important, you want an isolation sandbox. So you don't want the code that's running in tab 1 to access your banking application on tab 2, nor do you want code from any web application to access your system. So isolation is extremely important on the web. And as we look at the things that WebAssembly is promising and how they relate to the browser, we kind of start thinking about, well, the same things that make it appealing in the browser, cross-platform, cross-architecture, compact binary size, isolation, those actually make sense outside the browser as well. So we really want to explore using WebAssembly for server-side scenarios. And this is where the WebAssembly system interface comes into play, which aims to standardize the execution of WebAssembly outside the browser. And basically, the WASI lets you access the file system, networking, environment variables, all the things that you would normally use in a POSIX system, right? But I would like to introduce a very new proposal, which you can find on the internet, called the WebAssembly component model. And the way I usually like to talk about it is using an operating system analogy. And basically, if the core WebAssembly specification defines some low-level CPU instructions, like i30 to load, i30 to store, add, things like that, and on top of that, WASI models input-output interfaces, like file systems and networking, what we need is essentially a model that defines how processes are started and how they communicate with each other. And this is exactly what the WebAssembly component model is trying to address. Essentially defining a new binary format that enables cross-language composition. It enables a wide range of use cases that we'll look at in a minute. And personally, I think this really represents the future of WebAssembly everywhere. The component model is, these are the stated goals of the component model to enable scenarios like host embedding components. We hear people describing WebAssembly as the last plugin model you will ever need. Embedding plugins in all sorts of scenarios, from databases to serverless platforms to scripting environments. Pretty much everywhere you would need a user-defined function or user-defined functionality, WebAssembly might be suitable for those scenarios, particularly when you want to have isolation between those environments. Another big goal of the component model is to enable component composition. So, for example, reusing high-performance code from your JavaScript, right? Reusing a high-performance code in low-level C, or component dependencies from a registry and composing those through, for example, dynamic linking, when you want to define some components from a registry and dynamically link those at runtime. At its core, a WebAssembly component essentially is a way to put together multiple core modules and components and define a strongly typed interface that the outside world can use to interact with your WebAssembly component. And I think it really helps to have a look at a simple example. Basically, you're able to describe your functionality using an interface. This is the WIT format for WebAssembly. This is currently being standardized, and basically you're able to define functions and structs and records and results, pretty much similar to what you would do in your regular programming language. And then there is tooling that generates bindings for either implementing that interface and building WebAssembly components, or consuming that interface from other WebAssembly components. And of course, WebAssembly tooling is very, very popular in the Rust ecosystem, and all the things that I'm going to show you are both written in Rust and also have really good support for using Rust to build components. And essentially, if you want to implement this particular interface in Rust and generate a WebAssembly module from your Rust code, there's a tool called WIT BindGen, WIT being the format of the interface, that generates this Rust trait for you that you can then implement in your code. So basically, generate the trait using WIT BindGen and then implement this in your code. If you then build this Rust program and compile it to WASM32 WASI, those interfaces get exported as regular WebAssembly exports. And then the one other thing that I would note here is that, as I mentioned, the WebAssembly component defines a way to have a strongly typed interface to accessing functionality inside your WebAssembly component, and adapting values across that interface boundary is done using something called the canonical API, which essentially is a way to adapt a function, adapt high-level values from the outside world to the representation that your component uses. So an example for where you would need this is strings. JavaScript uses the WTF16 representation for strings. Rust uses UTF-8. The adapter functions would basically describe how to adapt an incoming value from one format to the other. And of course, the second aspect of this is consuming an interface, and you can also do that using the auto-generated bindings done by WIT BindGen. And this, after you compile your program, this results in the functions from the interface being just regular WebAssembly imports. So if you're familiar with the WebAssembly text format, this is just a regular WASM import. And this is where, having looked at WebAssembly, the new WebAssembly component model, this is where we are starting to have a look at Spin, which is a project that we recently launched. Basically, Spin is a framework for building and running event-driven microservices using WebAssembly components. It's built entirely on the WebAssembly component model that we've seen previously. And it's an open source project whose goal is to make it really, really easy to build and run your first WebAssembly microservice. And we have excellent support for building those microservices in Rust. Of course, Spin is built in Rust as well. And the primary thing we will have a look at is building WebAssembly components that can handle HTTP requests, but we'll see in a bit that Spin actually does a lot more than just HTTP. And it's a multi-language framework. It has robust support for SDKs for Rust and Go, but you can write an HTTP handler in any language that compiles to WASI. If you can compile your code to the WebAssembly system interface, to WASM32 WASI, then that WebAssembly module can be used as a Spin component. And we really think it's a really, really simple way to write fast and secure microservices using WebAssembly. You have a very simple application manifest that describes what type of application you have, in this case, an HTTP application. And then you have a list of components. In our case, we have one component called Rust-Linz. Define the WebAssembly module that will handle this component, and then some trigger configuration. In our case, which route is this component supposed to handle? And in our case, it should handle all requests coming to this application. And then you have a simple way of defining how you want to actually build and compile the WebAssembly module for this component. And as you can see, we're just using the regular cargo toolchain. So now that we've seen the application manifest, next thing is, what do we actually write? We do a Spin new, and then this is what gets generated for us. This is an entire Spin HTTP component. We have a hello world function that takes in an HTTP request and returns a result as an anyhow result using an HTTP response. The HTTP requests and responses are basically coming from the Rust HTTP crate, from the upstream crate that's used in all HTTP frameworks in Rust. And the only notable thing here is a proc macro, not the type of macro that Alvin showed us. This is a slightly different proc macro attribute that we'll see in a minute. And basically, it takes in the HTTP requests, the incoming requests, and then returns the response. Inside your function handler, you can do anything that compiles to WebAssembly. And let's have a look at running one of these from scratch. Spin, which is the CLI, has a list of templates that you can either use the built-in templates like HTTP Rust or HTTP Go, or you can build your own. We will do a Spin new and write a new HTTP Rust component. Write a description. And this generated a very simple Rust project for us. Let's open that.
Radu, I'm very sorry to interrupt you.
Yes.
We don't see, the screen was frozen. Now it works again. We heard you typing and you were describing something, but the terminal was somehow frozen. Now it is fine again. It was a temporary glitch.
Okay, thanks. Yep, the thing that the Spin new command generates is a very simple, in the case of a Rust template, a very simple Rust project. We basically have a cargo toml, source directory, and the only added thing is a spin.toml. So opening that in VS Code, we see cargo toml. We have a package authors cdylib library type that generates a WebAssembly module for us, and then a bunch of dependencies, anyhow, HTTP, as I mentioned, and then the Spin SDK, and with bindgen tooling that takes a WebAssembly interface and then does some behind-the-scenes magic. The other part of a Spin application is the Spin manifest, which is exactly what we saw before, an HTTP application, and then some component configuration. The actual code is just that, right? It's a one function annotated with the HTTP component, takes the HTTP request and returns the HTTP response. And the request and response, as I mentioned, are basically just HTTP requests, and they take an option of bytes. Nothing fancy there. What we can do is execute the build command for our application, which just calls cargo build using the WASM32 WASI target. successfully ran the build command, and then what we can do is do a spin up, and this will start a web listener on localhost, and basically all requests that are coming into this particular server will be handled by our component. So what we can do is curl and then see hello Fermion. Let's do a slight change to that. Hello Rust Linz. Save that, and we can do a spin build -- up, and this will recompile and actually restart our application. And this is hello Rust Linz. Now, I mentioned a couple of times that our goal with Spin is to build a way to help you create and run really, really fast applications. So let's run a small load test on our application for 10 seconds. This will basically bombard the web server with 5 concurrent connections for 10 seconds. And hopefully, if everything works well, we'll see that on average, for almost 200,000 requests, the average response times was 260 microseconds. So basically, this is the base the base scenario where the component doesn't actually do a lot, but you can. What happens behind the scenes is Spin will take the WebAssembly module, and for each new request, it will instantiate it, execute the Rust Linz function, and then return the response back to the client. So within those 200 microseconds, Spin does a lot of things, and the most important one is for each new request, you get a fresh WebAssembly instance that's entirely isolated from all the other requests that are executed in your process, on your machine. So at the beginning, we talked about the component model, and Spin uses the component model for everything. All Spin components are defined using WebAssembly interfaces, and all external services are defined as WebAssembly interfaces. So by default in WebAssembly, you don't actually have access to anything outside of your module. So if you want to use anything from files to making outbound HTTP connections to connecting to a database, everything has to be explicitly allowed, and Spin does that using the component model. For an HTTP request, basically it's fairly similar to what we saw in the cache interface. We have a handle-http-request function that takes a request and returns a response. And if we look at the proc macro attributes, this is basically what Spin does behind the scenes. Is if we remember how you can use the Rust tooling to generate a WebAssembly module that implements an interface, there's a trait that with bindgen defines for us, and then we implement that for our particular implementation. This is exactly what happens with Spin and HTTP. This is using the upstream with bindgen tooling to take your function that you define as the HTTP component and adapt that to be the entry point for a WebAssembly component. So this is entirely compatible with any tooling that's going to be compatible with the WebAssembly component model. And of course, we do that for everything else, not just HTTP. Spin has built-in support for handling PubSub with Redis. For every new message that comes on a Redis channel, you can write a function that implements this WebAssembly interface, which is fairly similar to the HTTP. Instead, it takes a message payload and returns an expected error. And then we're working on building timer trigger for cron jobs and things like that, that takes a clock event and returns basically a string. Hello World is great. We've seen Hello World in a dozen different languages for a dozen different projects in the WebAssembly space. But we wanted to build something a bit more. And if you go to fermion.com right now, or to spin.fermion.dev, which is the website for Spin, both of those are powered by WebAssembly microservices in Spin, and they have been serving hundreds of thousands of WebAssembly modules in the last couple of months. So we're actually dogfooding the things that we're building, and every time you visit fermion.com, you're actually spawning a bunch of WebAssembly modules that Spin executes. And besides that, we've built something called a manual load generator called Finicky Whiskers. So if you go to finickwhiskers.com right now, you will see an application that's built on top of Spin that has a bunch of WebAssembly microservices that are used to showcase how to generate load and how to do, for example, connect to Redis and things like that. So if you go to finickwhiskers.com, this is the website. If you start, you basically have to feed Whisk Slats, which is one of our teammates' cats, which was a very, very picky eater. And every time you press the button and it's the right food that Slats desires, you have a incrementing score, and we have this application running in our cluster on top of Nomad with the WebAssembly microservices that are running behind the scenes. You can play that right now if you want, but essentially it's designed to showcase how we think about microservices and containers in the future. And the game essentially is a static website that we've seen, and then 6 WebAssembly microservices with Redis running as a container in the background. And as you click the buttons to feed the cat, we're executing requests using Spin, and we're instantiating a new WebAssembly module on each new request. The faster you click, actually, the more WebAssembly modules you start. So if you are really, really fast, you can get a higher score. And it's just a load generator that happens to be slightly more adorable than your usual CLI load generator. Essentially, as I mentioned, there are a couple of microservices. Some of them are HTTP-based. Some of them are triggered by Redis PubSub. All of them are using external services, external persistence using Redis, using the key value store. And for example, for a played game that scores around 100, you actually instantiate over 250 WebAssembly instances. And as we've seen in our load test earlier on the CLI, each of those starts in around 200 microseconds, which is why we don't have a problem serving hundreds of thousands of them in short periods of time. You can try it out at finickwhiskers.com, and you can have a look at Spin on GitHub. github.com/fermion-spin. And I would encourage you to have a look at our documentation, which, by the way, is also served using Spin. Finally, I really want to say a big thank you to the WebAssembly community. None of the work we've seen would be possible without the amazing people working on standardizing and implementing WebAssembly, and in particular to the people building WASM time in the component model and all the tooling behind the component model. Any questions?
Hi, Radu. Thank you for the great presentation. That was very nice to see Spin in action. A question to the audience, please let your questions come through the chat. I will get started with some questions that came to my mind to just get the ball rolling, and we'll see what questions come in over time.
Sure.
One thing that I am particularly interested in is what is the async story? I mean, web handlers often have to do some I/O in the background. Maybe you want to access some kind of data store, database, might access the disk or whatever. Is there an async story? How does that relate to projects like Tokyo or the current standardization issues regarding async and futures? What are your thoughts on that?
Sure, that's a really good question. Not at all controversial. Basically, there are two main scenarios. If you're thinking about async inside your component, then you can use that today, right? There's nothing stopping you from using async inside your component. Mm-hmm. If you want to await a cross-component call, then that's also standardized with the component model. So that's not exactly possible right now. But there's an in-progress implementation for async and streams as well for the component model. So not available right now, but hopefully in the near future, you'll be able to async await across component boundaries.
Mm-hmm. Okay, very interesting. Thank you very much. We have one question from Alvin. He asks whether you can elaborate a little bit more how Spin does the WASM file calls internally. Do you use some kind of hosting library? How do you host these components? How are they called? Can you elaborate a little bit about
Sure.
how Spin does that?
Sure. So there are basically two stages. One is the startup stage, in which we load the WebAssembly modules from disk or from the network or from whatever method you use to distribute them. Currently, we use Bindle behind the scenes to distribute applications, but you can load them from disk as well. And basically, the startup stage loads the WebAssembly modules from the WASM files, turns them into a WASM time module, and then into a WASM time pre-instance. That is in the pre-initialization step, and then we essentially start a hyper server. And for each new request, we turn the pre-instance into a fresh WASM time instance that serves your request and then returns your response back to the client.
Okay, thank you. Thank you very much. Thank you. The next question comes from Pavel. He took a look into operating system interfaces a lot, and also into projects like Tokyo, and he saw that systems like Tokyo, they have to, he writes, swindle a lot because of lack of proper tools on the OS side. And he's a little bit concerned that WebAssembly will bring another operating system on the table, and he's not sure whether this might be a problem in the future. Does that make sense? Do you understand what Pop means?
It does make sense, and that's a really insightful question. Essentially, right now, when you compile your application, you have a choice of compiling that to one of the three big operating systems like Linux, Windows, Mac OS, or the browser. What WebAssembly does, and particularly WebAssembly outside the browser, it introduces just another target, another compilation target that is independent of the operating system and CPU architecture that's used to run on. So it is another compilation target, but we really think that the benefits that we see from compiling against WASM are going to be substantial in the future, particularly the isolation between the WebAssembly host and the code that's running inside the WebAssembly instance, and the portability and fast startup story are something that we will really see more of in the future.
Okay, thank you very much. Before we take the next question for the audience, I would like to ask one question, an architectural question where I didn't fully understand where Spin is going to. If you take a look at today's let's say, event-driven platforms, or even just take an example like Rust Rocket or something like this. Rust Rocket spoils developers. You get easy access to parameters, easy access to JSON deserialization. You have a powerful router and all these things. Where do you see a platform like Spin? Will there be a web framework inside of Spin, or will Spin, for instance, take the role of a powerful router? Are you going to build something like that into Spin, or does this question make sense to you?
It does make a lot of sense, and it touches on a lot of things that we've been talking about, both internally and with the open source community around the Spin SDK for Rust, which, as you see currently, is very simple. You annotate the function as an HTTP component with the proc macro attribute, and that's it, right? You define the routes outside of your actual code. We definitely see the value in having an internal router in the Spin SDK for Rust specifically, but what you should keep in mind is that Spin is a cross-language framework. So we have SDK support for Go. Our hope is to build, as more and more languages add support for the WebAssembly component model, our hope is to have more community-implemented SDKs for those languages as well. And what we're already seeing is overwhelmingly Rust has significantly better support for WebAssembly than other languages. And we're not exactly sure whether we want to build an internal router into the Rust SDK or delegate that to some other project or not. We're in the process of experimenting with that. So if you have thoughts and opinions about it, please file an issue. We would love your input there.
Okay, very nice. The next question comes from Matthias, a regular visitor of the Rust Linz meetup. Matthias asks whether there is a general bottleneck in Spin, or is there some code bottleneck that is generally slow and can't be sped up? What are the limits? And he adds then he was surprised that you instantiate a new WASM module for every request, and he asks how fast can that really be for even larger modules?
That's a really good question. I'll start with the first one, which is whether there's a bottleneck in Spin. And that is the biggest bottleneck is eventually going to be the networking stack on the machine, and how well we can handle the internals of either the HTTP stack that we're using for HTTP request responses, or the library to connect to, say, Redis or other PubSub mechanisms and things like that. The reason why the module size doesn't affect request response times is because we only pay the module compilation time at startup once, right? There are a couple of stages in the WASM time, in the WASM time stages, in where you go from read the module from disk, compile that just in time, and then you have a pre-instance. The pre-instance to WASM time instance cost is very, very small. And we only pay the big module price once at startup. So that's an internal optimization that we're using to ensure that even if your module is large, like a couple of 100 megabytes that we've seen in some cases, the request response time isn't affected by that. It's only affected by whatever computation is going on inside your module, and not by the compilation. And there are other things you can do, like ahead of time compile and WASM time caches, and a lot of things that can play into not paying the module size cost for requests.
Mm-hmm. Interesting. Thank you very much. I would like to ask an additional question concerning things like cross-cutting concerns. If you build a microservice system and you do some event-driven computing, you have a lot of cross-cutting concerns like logging or maybe validating tokens or things like that. Where do you expect things like that to happen? Is that something that the HTTP handler or the event functions inside of the WASM module should do? Or do you see Spin taking over some roles that traditionally are covered, like, I don't know, reverse proxies like traffic or things like that? Take the example of validating a job token, something like this.
Yeah. We currently don't implement any of that into Spin directly. What we hope we'll see in the next couple of months is features like that, like logging, like authentication authorization, being built by the community and having something that people just want and start using. We essentially want to keep the Spin core very lightweight and fast, focusing on the isolation and the startup times, and then layer on top of that either SDKs or additional components that people can just reuse. We already have a host of components that are reusable, like, for example, the file server that you can just drop in your spin.toml reference from a bindle, or file icon server and things like that that are just reusable components. And with logging as well, we hope to see the same thing, right? We hope to either get a WebAssembly interface that handles logging, or continue to drop to standard error and standard output, and Spin will collect the logs for that and show them to you. But we don't plan on adding anything built into Spin to handle things like authorization, for example.
Okay, interesting. You mentioned Bindle multiple times, and I've played with Spin, obviously, and played with Waji. And in Waji, there are examples where you can take something from an open source Docker registry. I tried it with the Azure Container Registry, but now with Spin, I've seen that you use Bindle, and I haven't read about container registries. What is the story there? Will you add support for Docker registries? Is Bindle the way to go? Where to read these things from? You know where I'm heading to with this question?
Yeah. When we built Waggy, the idea was to have a single component, single WebAssembly module, and if you distribute that using an OCI registry, that's totally fine. what we've seen with OCI, with our experience in the past with Helm and Kubernetes and a bunch of other projects in the container ecosystem, it's pretty difficult to have semantical meaning of the things that you're distributing inside the container image. And Bindle is a way to distribute multiple objects in something called an aggregated system. So we currently don't have any plans to add container registry support for Spin. If people want to add it, extending Spin is actually pretty easily done. So we expect to see someone from the community build container registry support. Our plan is to continue to use Bindle because with Bindle, you can distribute all the components in your application as well as static assets and other things that you might use in your application as well.
Nice. Understood. Matthias had a follow-up question. I think it's very interesting, a very interesting scenario. He was considering or thinking about whether it would be possible to auto-generate bindings to microservices, like he was thinking of a gRPC service, where we can take your services and maybe generate some gRPC or some open API specification or something like this. Any comments on that?
Basically you have two main options. The component model and the tooling around the component model allows you to do just that, right? You take a WebAssembly component and you have its interface, and you can automatically generate bindings that help you import and consume that component from your project, right? So you can do that right now, even without Spin. With Spin, you can continue to do that, of course. It's fully compatible with the component model. But what you can also do is, if the microservice you're using is defined in your application manifest, you can either use, for example, an outbound HTTP connection and just call it just like you would call a regular other HTTP service, or currently statically link the component in your WebAssembly module, which is currently a slight limitation of the component model, but one we will hopefully fix in the future.
Okay, let me close with a final question. We had the Crustlet team here at Linz multiple times. They were showing us what they do, and I was wondering, did you already try, or is it already possible to take a Spin application and use Crustlet to let it run natively inside of my Kubernetes cluster? Or is that still a way to go, or not even a meaningful architecture that I'm making up here?
So the team that initially built Crustlet, where some of the people are now at Fermion, some of them are at Cosmonic, some of them are still at Microsoft. The Microsoft team is looking at a slightly different approach, which is a container shim for WebAssembly. So instead of rebuilding the kubelet, you just create a new implementation for container D so you can run WebAssembly modules natively. And what they're doing is actually building a native Spin shim for container D. So you can run Spin applications right now in your WebAssembly cluster. I will share the link to how to do that in the Discord server later. But basically, you can deploy a Kubernetes cluster where a node can directly run native Spin applications.
Oh, that is very interesting, because that brings these microservices directly into the world of cloud computing, be it private cloud, public cloud, wherever you want it.
And on top of that, we're experimenting with the Nomad orchestrator and having something much more lightweight than the entirety of Kubernetes. So keep an eye out on projects that are using Nomad for the orchestration layer.
Super interesting. Radu, thank you very much. I don't think that we have any additional questions, and we don't want to stress your time too much. Thank you for this great presentation, for this introduction in Spin. I'm pretty sure that many people will now give it immediately a try, give you feedback, maybe contribute some code. So yeah, we are very thankful that you did the time, that you took the time to visit us here in Linz.
Sure, looking forward to all the contributions and questions from the community. Thank you so much for having me.
Very good. Thank you very much. Have a nice evening. Goodbye. Okay. thank you very much for watching the Rust Linz meetup. I would like to close with a final announcement. The date of the next meetup of the Rust Linz meetup June has already been set. It will be on the 13th of June, and our first speaker has already been announced. Take a look at the meetup site from Rust Linz, and you will see the first speaker. We are still looking into some options for a second speaker, and as always, if you have ideas for topics that you would like to present here at Rust Linz, be it your project, be it a book, be it a sample, be it some interesting learning that you had when taking a look in Rust, please get in contact with us, get in touch with us. We are always interested in contributions, in guest speakers from the community here at Rust Linz. So thank you very much. Thanks again to our two great speakers. And I wish you all a very nice evening. See you at June 30th to the next Rust Linz meetup, which will be the 23rd meetup here. Thank you and goodbye. Have a nice evening.